Hello legend, how are you doing? My name is Inks and I'm from IGS Electronics. Today we're going to be continuing with our S7-1500 series PLC and we're going to be checking out today digital input cards. Siemens has a variety of digital input cards, and as I will get them in the future, we'll be checking them out as they come. The most common one is quite weird, which I found different manufacturers or different people using different manufacturers' PLCs. They're different common cards they use, but Siemens very much is, no matter how many I've seen and worked with, they're very much pioneering these this basically the transistor cards. This particular one is a 32-bit, so it's got 32 outputs, and it's grouped in 4. What does 4 groups mean? We were talking about that in this video, so you understand how they work and how they are wired and what to look out for when you are trying to do your fault finding when you do have any issues with it. So yeah, that's what we've been doing today. So if you missed the previous videos, we already checked out the configuration, all the other bits when it comes down to hardware assembly, and also checked out the digital input. Those videos are part of the S7-1500 series playlist, so do check out if you wish to look at it. So without further ado, let's get started. Alrighty, as you can see, I have made some preparations. So we're going to be using 2 lights, which both are a 24-volt DC lights, and both, if you want to know the manufacturer by any case, they are made by Schneider Electric for their XB4 series. So this video is not about these lights, so let's crack on with the actual wiring. So let me just move this to this side, because this is where we're going to be checking out. So let's pull the wiring diagram. As you remember from if you watched the last video, well, most of the wiring diagrams are within their lids, within the card's lids. So as you can see, I have groups in here, or group 1, 2, 3 and 4. That's how we're going to call it actually, group 1, 2, 3 and 4. And each group, as it says, goes 1L, 3L, 2L, 4L. So we could actually call 1, 2, 3, 4 like that, but it doesn't matter which way you call it. So from olden days, you know, that L never used to be there. So now the L is there because you can see the P's in here. And that was implemented to monitor the actual power supplies itself. So that powers this particular section of the card. And if the power supply power would disappear, it would let you know that there's a problem, and it's basically for fault finding. Very good. I'll show that in a minute. What happens if the power does disappear? So each section is L1, L2, 3 and 4, and then it's got M's as well. M's are negatives and L's are pluses from power supplies. Each one of these sections can live with its own power supply. It doesn't have to have one power supply for all of them. If you have a 4 different, quite a big machine, but you are sending signals from 4 different areas, you can segregate these areas. Not sending, but the card would send signals out to the different areas that are powered with have different power supplies on there. You can do that. So as you can see in here, it's got the pins in here. These pins in here indicate that these 2 are joined together. So the section, in our case, as you can see down there, the section 1 and 3, what you call it, those are joined together, and they're using one power supply. It's a good hint that if the pins are there, they're using one power supply. As you can see, it's got pins down here as well. Those pins can be easily removed. I'm going to show that in a minute. So when you see that, when all 4 pins are in there, it's very likely that the card is using just one power supply and is outputting signals just using one power supply, one 24-volt DC. But that does not mean necessarily that is the case, because what I have done in here, these wires in here and these wires in here, they come from different power supply, and often when it comes down to control panels, if the professionals have done it, they usually would put some form of indication on the cables if that is the case. And because I haven't put it because it's for testing purposes, but usually when I do the wiring, I will put indication for whoever's trying to fault find to make understanding if it is at the same power supply. That's the key, guys, for you to understand, to make sure that you know how these sections here are being powered, because that determines You see this black cable that comes out and it goes to the lights plus? That determines the end of it. That determines which power supplies negative should be used for whatever you are trying to turn on. In our case, it's lights. It could be relays, it could be coils, it could be I don't know, solenoids, whatever. Now that determines where that part receives that negative. So if this power supply is powering this section in here, I need to make sure that that negative, this white in here, is powering my lamp's negative as well. If I mix them, they will not work, because it has to be, when the power comes out, it has to return back to where it's come from. And if it doesn't, it just doesn't, well, it's just not going to work. So that's something really important. I'll show you in a minute what happens if you do mix them up. So as we determined, just to go have a quick recap, do pay attention of these pins. Make sure that you understand these parts in here. So make sure that if you want to quickly test it, you can test it 24 in here, and then you can use this negative in here and run all 4 pluses. Make sure they are all returning the reading for you. If it's not, then you have different power supplies. So that is a crucial, because in my case I'm using section 1 and 3 is using one power supply, and section 3 and 4 is, no, it works out 2 and 4 is using another power supply. So I have, let's quickly jump onto the laptop, because what we're going to do, we're going to turn on the L wire break diagnostics, and I'll show you what happens when power do disappear from this card. I think it's a fantastic addition that Siemens has implemented in their I/O cards, and I absolutely love it. So let's jump on it and see how can we turn it on and off. There we are. This is the little program that we're going to be using to switch those outputs on. So basically, input at 1.7 is going to be turning on output 0.7, and input 3.7 is going to be turning on output 1.7. Just to quickly show you how easy it is to get to know which one is which. You can just use into the device view. Go into 200% and you can see all the outputs. It pretty much shows you each place where it is, and pretty much, yeah, it's quite straightforward. You can actually drag and drop if you wish to, but again guys, there's so many people already done those videos of how the programming works and things like that. So this is basically what we are going to be doing in here. So our input 1.7, so where are we? 1.7 right down here. And input 3.7 is this guy right down here, and outputs are the same. So the ones this output and this output is the ones we are going to be using. So let's turn on. Let's go on to the device configuration, which would actually be down there, but I no longer want that. So let's remove that. Let's go on to the card itself. The card itself's got quite a nice diagnostic section in there, but one we're going to be concentrating is the wire break. So let's go outputs, as you can see, there's all the groups, 0 to 7, 8 to 15, 16 to 23, and 24 to 31. So each group, as you can see, there's a channel and there's a general, as you can see in here, just by clicking on that one as well, or you can, if you go into general like that, you can see this no supply voltage L. So let's turn, not for this group, because that's not the one we're going to be turning on. Each group can be done separately if you wish to, quite nicely. So we are just going to do a group, no, that's 1, 2, no, not this group either, because it's 1 and 2. So this group, we're going to put L in no supply. Oh, come on, no supply. Did we turn that off there? So let's remove that one. So now if I remove from the cable from group 3, powers from the group 3, the error should appear on our output card telling you we have a problem. So I don't know why people wouldn't use it. I think it's by default it's not turned on by default, so it can be turned on anytime, as you see what I just did. So let's go back on our thingy on our setup and see how it works. So before we check out how the wire break works, so as you can see in here, what we're going to do, we're going to be using these 2 buttons. So you can see both lights are coming on. So now this guy in this group in here, from this power supply, as you can see, this power supply is sending once the output gets turned on, it's sending 24 volt into my plus side of my lamp, and my negative, as you can see, is joined in here. It's getting negative from there as well. Usually it would come from the power supply, some form of sections down there, but I chose it from there. And the other one, as you can see, my negative is coming to this guy in here, and my plus, as you can see, is coming from, in our case, you could see that is a terminal 17 there. So that's our second output. So if you turn on, as you can see when I click to flip the switches, in here, both of them are coming on because the wiring is correct. For fun of it, let's mix them. So here we go. So what we're going to do in here, we're going to put negative in this one, which is not how it's supposed to be, and see what happens because we just mix them up. And we're trying to flip it now. As you can see, nothing happens. That's why, ladies and gentlemen, it's very crucial for us to understand which power supply is doing what. So that will do for now regarding when it goes. Hopefully that really makes a good sense for you and a good understanding how this wiring could possibly work. So now what we're going to do, we are going to remove this pin, which will eliminate power to this P. So this P right down here will lose its power, if I done my config correctly. And boom, that P disappeared. And as you can see, my red light is flashing now. And my CPU is gone in an error. It didn't stop, but it's gone into error. So let me just remove that light a little bit off so you can see what is what. So let me just move this. My light is coming in a little bit too much. So let's go down to the thingy. As you can see, my CPU is flashing red. So let's see what message are we getting. So let's go down a little bit. And actually, I can't see because the light is on there. So let's click OK. We got alarm. And what does he say? It says the supply voltage missing is brilliant. Look at that. I love this screen. It tells you exactly where the problem is. Okay, and it says in there 32 channel. It says which card is lost its power. Fantastic. So from there on, you can go on and figure out how to fix the problem. So what we are going to do in here, we are going to plug it in. So bang, and voila, error disappears. And that, ladies and gentlemen, will do for this video. Hopefully it is made a sense to you guys and you are well on your way understanding what we are trying to do in here. Again, this channel is not about programming. It's all about understanding that hardware, which is very, very important when you are out there in the field and fault finding the control panels or systems. And that, thank you very much for watching. If you liked the video, don't forget to smash that like and do subscribe if you're new to the channel. See you next video.